Ayan George, and I live in Orlando, or the Orlando area, and uh, I have two talks today. Um, I'm going to try my best to fit everything in an hour. The first talk is about time formatting in Go. The second talk is about fuzzing. I'm not an expert in either of these things. My purpose, or the reason I do these kind of things, and the reason I give talks, is because what I find is that the best way to learn something is to like try to explain it to somebody else. And so what I typically get out of this is that I always learn something. And so to that end, what I'd like is that I get feedback, right? So if you guys are here, what I'm hoping is that if I say something wrong or if I say something and you have questions about it, that you unmute yourself and you ask me right away. I don't mind like interruptions. I don't mind questions. Um, I'd like to kind of try to keep everything within our time frame, but at the same time, I think we get the best sort of like bang for our buck or best impact if we actually learn something. And I don't want to like spread misinformation or anything like that.
Also, just really quickly, A, and in the spirit of that, if people are more comfortable, if anyone's intimidated, not intimidated is the wrong word. If you prefer that this not be recorded and put on YouTube, in that does something in terms of your interest in participating, I'll go ahead tonight and turn off the recording. So I'm really good with that and can commit to that because again, it's about the interaction. It's not about the putting it up on YouTube. So if people can direct message me and let me know if they'd be more comfortable with that, and I will be more than happy to do that if that will allow people to feel more comfortable. Okay, thanks.
And just to encourage anybody, like I have to admit, I feel a little bit weird about it. I mean, I personally have ended up on YouTube and that kind of thing, but I get it. So if you're like uncomfortable, I don't think I would be offended if you spoke up. Um, but I guess another thing that I'd like to get out of this is that obviously I'm not perfect, and so I hope what you see or what you feel at the end of this is that if I could do this, then you definitely can too. So that's like the big thing. So let's start by presenting, and let's see if I could get this to work. Share. All right, so you should see a blank screen, blankish screen. Oops. And here's my browser. Cool. So did anybody have any problems seeing my screen?
Nope.
Or let me ask a better question. Does everyone see my screen?
Yeah.
Sweet. And that's the thing. So remember, I can't see you guys because I'm looking at my screen. So if I ask a question, please, it helps me if you like unmute yourself and actually speak, because again, I hope this will be more of like a conversation. So I'm expecting feedback and I can't see your faces right now. So anyway. All right, so here we go. Time formatting and Go. There's a couple of things that made me write this. Actually, a good friend of mine, Vladimir Vivian, we were working on a YouTube channel, and we made like a couple of attempts at like writing this, or I'm sorry, recording a session on time formatting, in part because there seems to be a lot of confusion about time formatting and Go. And I'm going to illustrate. So I've already gotten done with the introductions. Hi, everybody. And so on this first slide, obviously you can't see the link, but here's some complaints about Go's time formatting. It says, I find this unnecessarily painful. It's hard to remember without looking at the documentation. It's extremely confusing, and it breaks for no good reason from the strftime standard format, which has been in use for half a century. This guy's really upset. Another one, so confusing. It's as if they were trying to port .NET's formatting syntax to a slightly more verbose version of BrainF. He really dislikes it, right? Even more complaints. So I'm willing to bet that most non-US developers would fare much better with strftime-based formatting, as opposed to the abomination, while they call it an abomination, that the standard library provides. And there's this really interesting website. I don't want to violate kind of our code of conduct too hard, but it's called effinggodateformat.com. Somebody actually registered a domain name, and apparently at some point they thought better about it because it's only available on Web Archive. But when it comes up, you'll see that what it allows you to do is convert strftime formats to Go time formats. And from my perspective, actually, it should be the other way around. And I hope that everyone here feels that way by the end of this talk. Gosh, I even found another one. All right. So you get more complaints. The Go way of parsing strings in the data is pretty confusing unless you live in a small fraction of the world. Okay, we'll cover that. All right, but so far we've already talked about strftime a couple of times, and I'm an old C programmer, and I'm very familiar with strftime, and I've used it quite a bit. And so let's start by talking about what strftime is. So strftime is C's standard time formatting function, and it uses a pattern comprised of special sequences, similar to like printf verbs. So it starts with like percent and then some character, and what those do is each kind of represents the format of some portion of this TM struct, which is the struct that you get back when you run functions like GM time or local time or whatever, like in C. And so these are part of the C standard library. Therefore, I'm sorry, these are part of the C standard first off. So it's a part of C99 and POSIX, and therefore it's going to be in libc. And so what libc is a shared library that most like C programs are linked with when you compile a C program. And what that means is that programming languages that are written in C often inherit strftime just by the fact that the strftime function is available in C. You write something like PHP or Ruby or Perl or Tickle in C, and you automatically have strftime. So you kind of hoist that functionality out of C and directly into whatever language you're implementing it. And so in that way, it's kind of proliferated, right? So you have a strftime like equivalent in a lot of languages. And so people are used to it, right? And maybe rightfully a little bit confused when they see it in Go. I mean, when they don't see it in Go. So what do these patterns look like? Here is a list of all the patterns. I think I yanked that out of the FreeBSD man page. So it's slightly different under Linux, I think. But those are the strftime verbs. And so what I'd like you guys to do is memorize this, because on the next slide, there's going to be a quick quiz. You guys ready? So I'm going to give you a few seconds. Let me know when you've memorized it. Count down. So maybe 5, 4, 3. All right. You guys have it? Let me know.
Sure.
All right. Perfect. All right. So let's play with strftime, right? So what I'd like to do is, using strftime, I would like to format today's date, right? Wednesday, September 22nd, 2021, exactly like that. Can someone tell me what verbs to use in order to do that? Or what, like which one of these, or what combination of those can I use to format this time? Oh, you had like forever to look at this. Come on, quick. No? All right. So I have my notes here. I'm going to yank that off the screen. And I'm going to open a terminal. And we're going to play with this just for a moment. All right.
Would you start with a W?
What's that?
Lowercase and uppercase W as a weekday, or?
Okay. So here's I don't know if it's a little known fact. I've known this for a couple decades now, but the date command will format the current date using strftime if you say plus. And so anything after the plus, you can supply strftime format verbs, and it'll give you the exact output of strftime. So I've always used like plus R, right? If I want to know the time right there. All right. So I don't know who said W, but I would love you to kind of help me construct a strftime string or pattern that would output this. All right, go ahead. What is it? Capital W, you said? Hello? All right, that's 38. I don't know what that means. Lowercase w? All right, that's 3. I'm not sure what that is either.
So 38 is the week of the yearly week in a year, maybe.
I've never in my life needed to know the numbered week of the year, but okay.
You've never been in manufacturing.
What's that?
It's important in manufacturing for serial numbers.
Okay, all right, granted. So I happen to have in my notes that capital A is the full name of the week, and of course that's in the man page, right? So the first couple are gimmies, right? So like, because you have capital A and then you have capital B. All right, so we'll go with that, right? So capital A, capital B, boom. Wednesday, September. Okay, comma. Let's do capital, percent what? What do you think is going to give us the day of the month? Is it maybe capital D? How about just lowercase d?
Lowercase.
We're getting somewhere. And now we want the year. All right. Hold on one second. Yes, sweetie. You good? What? Quick.
Can I watch that though?
Yeah. On the big TV.
Like the anime.
Yeah. You're good. Yeah.
Okay.
All right. I'm sorry about that. More kid stuff. Being at home. So yes, we had percent A, percent B, percent D, percent Y. People seem to get upset when they're missing shrift time. But it's almost like this weird like Stockholm syndrome. We've been like abused by this because I personally have as long as I've programmed in C, it's very rare that I have had to use shrift time to format a time without looking at the man page. Like pretty much, I would pretty much say never. It's been so rare that I would say never. I can't remember a time when I didn't have to go to the man page. And so all these people who are like upset about Go's time formatting, I think they're missing one of the most beautiful things about time formatting. So let's move on to the next slide. All right, so now let's play with time format. And so one of the things that kind of made me work on this is that there's a recent commit to the Go master branch. It's actually Rob Pike himself who made this commit that actually updated the documentation for Go 1.17. But more importantly, he added some new constants to the time package. So let's take a look at that. So if we do go doc time, of course, we're going to go to wall of text, right? But one of the cool things is that this new layout constant is brand new, right? And that was added in that commit. My dog is going crazy right now. Stop it. So this layout actually explains kind of demonstrates what the layout for time or pattern for time actually is, right? So before this commit, it used to be time.NC. C, that was like at the top, right? And that was this. But now we have time.layout, and that pretty clearly lays out everything, or that pretty clearly shows everything. But more importantly, he goes on to clarify the documentation further down, right? But the most important part, or one of the most interesting parts, I think, is this right here. But I'm sorry, let me rewind. Let me rewind. Let's take a look at time.layout. Can anybody tell me anything interesting about this format or this line here? Like you see anything?
A sequence?
What's that?
It is a sequence.
Can you?
Yeah,
elaborate?
easy to remember.
Yeah, so we see 1, 2, 3, 4, 5, 6, 7. Oh my God, right? And so what I'd like for us to get out of this talk is that by the end, we will have developed an intuition about how to format time such that we will never have to look at the documentation. We won't have to look at the man page like we would with strict time, nor we would have to look at like the Go doc. And so as you can see, it's just 1, 2, 3, 4, 5, 6, 7, right? And so let's do something fun. Let's do this. All right. So we're going to play with time. And so we're going to say like now equals time now. Oops. And then we're going to say scanner equals bus bio new scanner. What is it? OS student. And then we're going to say prompt printf. We're going to put a prompt. And then if scan, or if not, scan break. Otherwise, let's say prompt printf %s, new line, now format scan text. Yeah. and that should compile. Why is this complaining? Oh, no, it's not complaining anymore. All right. All right, so go, do we have module? Yeah, go run, PM. Great. All right, so we had that 1, 2, 3, 4, 5, 6, 7 thing, right? So let's try a 1.
Month and digits, I think. Yeah.
Yeah, so that's the month in digits. What if we said 02? That's a day. Can you imagine what 03, 04, and 05 are? So month, a day.
Hour, minute, second.
All right, so you could say 03, 04, 05, 726. Pretty close, 11 seconds, at least at the time that now ran, right? What if I wanted the 24-hour notation for the hour? Like, so it's 7 o'clock, but that should be what, 1900 hours, at least here in Eastern. So what,
15 or 4 or 5.
why 15?
Because that's what we use outside of the Anglophone countries.
Well, let's,
Yeah, it's 12 plus 3.
right,
Or
right. That's exactly it, right? So 15, right? So that's basically 3 o'clock, but in non-Anglophile, Anglophone countries. Right?
That's a question. Sorry to interrupt. Why 15? I know it's 15, but why 15?
What's 3 o'clock in? So the 3 is the hour, right? What's
Right.
3 o'clock in 24-hour notation?
Sure, that's 15. But what does 3 signify?
So it's just a placeholder, right? So the format is 01, 02, 03, 04, 05. I'm lost on 6 right now. So we're going to skip 6. Oh, no, yeah. I'm sorry. 2006, 07, right? So we're counting up. And so 3 happens to be the placeholder for the current hour. But 3 itself is for the 12-hour clock hour.
Oh, I see. Okay. Yeah,
But,
understand. Okay.
but we want the 24-hour clock hour for 3,
course, yeah.
which is 15,
Understood.
right?
Yeah.
Right. And so
I
we
missed
did
that.
the same thing.
So, yeah, okay.
Oh, sorry. Right? Oh gosh, what am I doing here? I'm sorry. Well, you get the gist. So let's run this again. Let's reset our terminal. So now there's actually a few things that don't follow that pattern, at least not directly, right? So take, for example, like what if I wanted the name of the month? Which month would I use? And you could actually use the pattern that we described, right? 01, 02, 03, 04, whatever. We could use that pattern to kind of deduce what or how we could do the months.
In this case, it would be the same as the name for the 01 month, which is January.
I'm sorry, real quick. Can you guys hear the rain as badly as I can? It's raining outside right now, and I can almost.
No.
Okay.
No, you're fine. Yeah.
Okay. All right.
Yeah.
Okay. So what was that again? I just changed my mic setup.
01 represents the first month of the year.
Okay.
So the first month of the year is January, and I assume that the string representation of that is January.
All right. You sure about that?
I would type January.
Yes.
All right. So of course, January expands to the current month. Of course, the abbreviated January corresponds with the abbreviated current month. Similar story for days of the week. Of course, it doesn't quite like map because there's no like numeric placeholder for like the day of a particular week, but instead we use Mon or Monday, right? For fractional seconds, right? So if I say dot 99999, I get that. Or if I say dot 999, I get just 26. But notice that I truncated it, right? So I wanted 3 digits precision, but I only got back 2. Does anybody have any like intuition about how I could ensure that I get 3 digits of precision out of this? Well, the way is to use zeros instead, right? And that will print as many digits of precision as I need. And so, and I guess again, you could look at it's raining and my dog is is not is not liking it. We could look at the documentation for more format primitive or format replacement strings. For example, the actual string time zone is MST, but what I'd like to do now is, there's one interesting one that I think we left out. You can actually print the actual number of the day of the year, right? So you have 2, that shows the day of the month, it's 22. If we are on a 2-digit day, so for example, let's see, I guess you could say time now sub 24 times time hour, or 24 times, let's say 20, right? Times time hour. So that'll push us back in time 20 days. So we should get a 2, right? So, sorry. What's going on here? Let's try add. There we go. All right, so if we do a 2, yeah, so we're in the 2nd day now, right? So today's 22nd, we just knocked 20 days off of it. So the current day is a 2. If I just said 2, of course it'll print 2. This is confusing because 2's, I took 20 days off, I'm sorry, but believe me when I say that 2 is the actual 2nd day of the month that it's printing. But now if I wanted to print 2 padded with a space, I could say _2. Or if I wanted to print the day of the year, it's still 2, but I need to show it in 3 digits of precision. So I could say 002. And today's, or at least the 2nd of the month, was the 245th day. If it had been less than the order of, if it had been smaller than like 100, then I could have done __2, and that would have printed whatever it was. So if we were in the 10th day, that would have just printed 10. But so those are some additional things. But so now, after going through that, I'd like to revisit. I'd like to revisit our little exercise here, and I'd like to know if anybody could tell me what pattern they would use in order to generate that string without looking it up, just off the top of your head, like real quick. Brian, I see you.
Monday.
Okay, all right. So Monday.
January.
January.
Oops.
Yeah.
Okay.
02.
02.
And then
2006.
Oh,
Look at that. And so without looking at a man page, without looking at the docs, and so for all these people on Reddit or who are writing blog posts about why they're just kind of shaking their fists at like why Go doesn't have shrift time. This is why Go doesn't have shrift time. And I think this is so much better. As somebody who's like programmed in C for a long time, this is one of the many like refreshing like not changes, but one of the many refreshing things about Go that makes me like not miss C at all. So that's all I got. I feel like I went way over on my time talk, and I'm feeling a little stressed about fuzzing. Is everybody still good?
yeah, you're good.
Yeah.
Okay.
You didn't go over. Good.
Okay.
Yeah, you're just on time.
All right. All right. The clock says 19:35, but I guess we had a little bit of stuff before then.
We started late.
Yeah. Alrighty, so let me refresh, context switch to fuzzing. Does anybody have any questions about that? First off, like, did anybody learn anything? Did I convert anybody from strftime or anything like that? Or did everybody already know this? Should I just skip that part?
So I I have a question, and I'm not sure if you'll be able to answer this or not. I think that the 1, 2, 3, 4, 5 is really neat, but the year is not next to the month and the day in that line. Do you know why that is?
I don't know why. Like, I couldn't tell you why for any of that. Yeah, I have no idea why. I feel like, yeah, I have no clue. And so even in that commit that I pointed out, Mr. Pike points out, or I think it's even in the docs. I think he calls it sort of an unfortunate. What is it? Let's see if I can find it. Oh gosh, I wish I could find it. Here we go. Yeah, it is a regrettable historic error that the date uses the American convention of putting the numerical month before the day. I guess my point about that is, I feel like choices were made at the time. I obviously I can't tell you what like reasoning went into it, but I think the most important thing to understand is that the order and what each number kind of represents, maybe to some degree doesn't matter. Obviously, it would probably be more difficult if, like, you know, there was no like reason, there was absolutely no order to it, right? If it was like,
right.
But my point is, there is kind of an order to it that you can remember, regardless of what part of the world you're in or whatever, and you could easily memorize it. And I think in that way, where these things are kind of irrelevant. What's most important is that it's easy to remember, and that's it. Does that kind of answer your question? Or
Yeah. No, I'm sure that whatever reasoning is there is lost to time. In a perfect world, the year would be closer to the month and the day. But I agree with you. I think that you're absolutely spot on. That the way it is very memorable. And even though the year is off a little bit, I don't think it matters.
Right. Yeah, no, I get it. Like, I feel like I do have, well, so let's flip it, right? So what would happen if we put the year after, well, let's say, okay, so I feel like ideally it would be like
Year, month, day.
Well, maybe day, month, year, I think is what, or maybe year, month, day, right? So
well, either of those would be not really American, I think.
Right. And so those are some of the complaints, right? That this
Yeah.
is sort of like American centric, and maybe, and I actually reject that, right? Because this isn't dictating how time should be outputted. This is just outlining how Go maps portions of, or, you know, parts of our time to numbers, right? And obviously how you end up rearranging this to format time will depend on what region you're trying to cater to, or whatever, or not cater to. That makes sense.
Right.
So, like, anyway, that's it.
There's also benefits to year 2006 because the 1st of January is a Sunday and the 2nd is a Monday. So you can remember that first month, 2nd day is a Monday. So it's the first day of the week for many of us.
I accept that explanation, and I wish I said that. So thank you.
Yeah, I looked up the 2006 calendar, and that's how I figured out it was Monday without looking in the man.
Perfect. But then there's gonna be one person who complains that they start their weeks on Sunday, and that all of this is completely bogus, and we should use strftime because it's superior. But, you know, I guess you can't please everyone. But yeah, that's great, and I learned something. So I feel like this has already been worth it. Anything else before we move on? Bueller?
I'm good. I think it's good. Thanks.
Sweet. Okay, let's move on. All right, so hey, my name's Ayan George. Oh, I forgot to change the date. So I just want to talk about fuzzing. I am not an expert in fuzzing. I just thought it was super cool because I tend to use like Go's master branch just because it rarely. I've actually when I say rarely, I've never had a problem with using Go's master branch, and so especially at work, I found a bug in some of our code using fuzzing just by playing around, and I got to talk about it in one of our little internal meetups, and I thought just the idea of fuzzing is completely cool because it was my first exposure to it. And so what kind of instigated that was this blog post saying that Fuzzing Beta is ready. And this is back when it was sort of sequestered into its own branch. I think it's called like Dev Fuzz. And so I checked it out, started using it, and it's super cool. But recently, we had this tweet indicating that Dev Fuzz is actually merged into master, which is also cool. So that means that if you use Go tip or use Go from the master branch, you have fuzzing built in along with type parameters. So and so I think also what this means is that we will probably most likely see fuzzing in Go 1.18. I don't know because I am not on the Go team and I have no insight into that. But I think it's a pretty clear hint, right? That since it's in the master branch, that we're going to see it in 1.18. And so again, please, if anyone has any issues with anything I say, please stop me. And because I am not an expert at this, and I'm learning along with you guys. It's 7:43. I'm gonna try to fit this in 15 minutes. If I have to hard stop, I will, and I apologize for that. But so with that, let's dive into it. All right, so what's fuzz testing? It's a testing technique that supplies random data as inputs. The two good uses I found was simply supplying unforeseen inputs to functions to aid in finding bugs. As developers, we can get kind of myopic. I know we all are probably familiar with table-driven tests. And, so we as developers have to come up with inputs. And I have seen personally people let's say working on string related functions and not use empty string or slices and not use an empty or nil slice, obvious inputs that would throw things off and completely leave those out of tests. But then there's a whole wide infinite range of other inputs that you could supply that as programmers we tend not to think of. And so fuzzing does that for us. What fuzzing does is it adds the following parameters to Go test. One is -fuzz, which is very similar to -run. It allows you to specify a pattern that selects fuzz functions. The signature for fuzz functions are func, capital fuzz, and then the rest of the name. And it's very similar to test or example or benchmark, except for it's capital fuzz. Fuzz time indicates how long to fuzz for. We'll talk about that in a sec. Keep fuzzing. Right now, if fuzz finds a problem while it's fuzzing, it'll immediately stop. And keep fuzzing. I think the intention of that is to say, if you find an error, just keep fuzzing until fuzz time or into infinity. But currently, it doesn't do anything. And there's a couple others. I'm not going to bother to go into the last two parameters of Go test, but then we have Go clean adds the fuzz cache. And so essentially, we'll talk about this in a bit, but fuzzing is is more than it's coverage sort of directed. So it tries to kind of worm its way through your code, and as it finds inputs that reveals new coverage, I think it stashes it in a cache. And so saying Go clean -fuzz cache removes that data from the cache. So additions to the language. So you have testing.f, it's very similar to testing.t. It has a lot of methods hanging off of it, but the new ones are .add and .fuzz. And I believe testing.f adheres to or implements testing.tb. So we have all the related methods associated with that. So like if we did something like go doc testing.tb. So in order to implement testing.tb, you have to do all this other stuff as well. And I'm pretty sure that testing.f implements that, which makes me realize that it looks like they may have like painted themselves in the corner, right? Like maybe that interface should have been named something better than testing.tb. Like, I don't know. I think testing.testable is probably bad too, but now that Fuzz implements it, what are they going to do? Anyway. All right, so fuzzing behavior. So by default, fuzzing behaves like regular tests, actually. And it almost works very similar to like table-driven tests, where you provide a corpus, like a body of text. So you supply a body of text to the fuzzer, and then you provide a function that the text is, or actually, I'm sorry, when I say text, it's not just a corpus of text, corpus of data. And then you provide a function that accepts that data, and it's mutated. Well, actually, I'm sorry. By default, it's not mutated. It's just passed directly to your test function, and your test function takes a testing.t, and so it behaves very similar to like a regular test. And so if whatever logic you have in there to test your routines fails, then it'll fail like any other test. But when passed a -fuzz parameter, then that's when the fuzzing actually starts, and the fuzzing actually happens, right? That's when it takes this corpus of data and start mutating it in interesting ways to provide like unexpected inputs to your fuzz function. And one of the cool things is that fail. Did you guys hear that?
I heard that.
Yeah.
Whoa.
Yeah, that was like crazy loud. Okay. So since I have on headphones, I can kind of hear like the rain going on, but I think we're having like a bad storm outside. So bear with me. I have UPS, so if I lose power, we could kind of keep it moving for a little bit. But anyway. Cool thing is that fail tests are stored in the test data directory, right? And so as you're aware, test data is a special is a directory that's treated specially, right? So like any of the functions or any of the commands that sort of recurse down directories will ignore test data. So if you do like a go test // and that tells it to kind of like walk the directories, it'll skip test data. And so that's where you can kind of put things like, you know, like I think I've seen like there was a great talk by the guy who started HashiCorp. And he uses like test-fixtures, but that actually kind of breaks this, right? So test data is actually ignored, whereas I think test-fixtures will actually be like included in that like recursion maybe. So anyway, it encodes the failure in a special file in the test data directory that allows that failure to become part of your tests permanently. So once you fix it, you can continue to test for that, so that to avoid regressions, and we'll see that demonstrated. And so again, fuzzing is coverage guided. So that means that in a way it can be classified as a gray box. And if you want to like look at or read the Wikipedia page, there's classifications of like types of fuzz testing. But gray box in particular means that it relies on instrumentation to direct the mutation based on code coverage. I'm hedging here a little bit because I'm going by like by the source or what I've read in the source, but it seems like the operation of fuzzing is to mutate the inputs, pass it to the code that's to be exercised, and then store any inputs that expand coverage, right? And so what it does is I think it keeps track of like the AST and kind of like annotates like how many times each node has been visited, and as it finds a new kind of corner of your code, it goes, hey, that's kind of cool input. So it kind of stashes that so that it could reuse it to generate new inputs. And so of course, like I said, and once a test failure occurs, Fuzz attempts to minimize the value sent. So like if the value it sent was like this crazy long string, it then attempts to like whittle that string down to the shortest value that actually triggers the failure, so that you get only the thing that triggers a failure, which I think is super cool. And I think that's how it works. If anybody knows the innards of fuzzing better than I do, please interrupt and let me know. But this is based on my reading of the source. And finally, they're mutators for most of the base types. And I say most, I actually think all of the base types. And what I kind of struggle with is the word base types. What I probably should have said was like atomic types, right? Like uint 8 or like int or float 64 or something like that, right? Those are types that aren't comprised of other types. It does not support composite types like maps, structs, or channels, but it does support byte slices and strings. And so those are the two like kind of composite types that it supports. Everybody good with that so far? Does that make sense? Kind of.
Yep.
Cool.
Yes.
Cool. All right, so here I point to some source. I just like this because it had to be cool to kind of like think about how to like mutate inputs. All right, like so here's the actual type switch that determines which mutator to use based on type. And as you can see, it does kind of cover all of our sort of like fundamental types, all of our ints, floats, bool, rune, byte. And of course it does cover string and then a byte slice. And then we have this nice default label that for anything else. And so what I'm doing here is I'm hoping I'm proving to you that what I said in the previous slide is correct, which is that we don't support, or that fuzzing doesn't support other composite types. And I think this is the real fun part, right? So this is the actual mutator, and this has actually changed a little bit over time, but as I think this line is interesting on 289, where we select a random mutator out of this slice. And so it reuses byte slice mutator for strings and byte slices because their underlying representation is really similar. But that selects one of these 18 different mutators. And, so it does cool stuff like flipping bits or XORing bytes or swapping bytes or shuffling bytes and that kind of thing. And I thought the process of like going through these and figuring out how you can like screw up people's data must have been fun. Yeah, that's it. All right, so here's just some kind of thoughts or opinions. Please, like I'm not trying to like pontificate. This is just like kind of my takeaway from fuzzing, which is that it actually is kind of hard, right? I tried very hard to find instances where fuzzing like works essentially I tried very hard to find like applications for fuzzing, and for some things it simply doesn't work. What I found is like the easy things are like invariants. That's like functions that always return the same thing. For a given input, it will always return the same output. And then of course subsets of those, right? So functions with inverse functions, right? Like so take one function like a JSON encoder and a decoder, and you can kind of use those to kind of like check your work, right? And then yet even tighter subset of involutory functions, like where the inverse of a function is the same as the function itself. So like obvious one is like strings reverse, right? Obviously there's also some trig functions that work that way. One thing that I found is that that fuzzing requires, fuzzing is is only as good as a corpus you give it, right? The mutator does a lot to kind of change or provide new inputs, but it's up to you to provide a good sort of base that the mutator can start with. And what that does is it will also avoid like aimless mutation, right? So if like you don't give the corpus a good, if you don't start with a good corpus, it could mutate it all at once, but it may not ever find those like edge cases because you didn't start it with anything interesting or anything that kind of arrives at those edge cases. So let's code a little bit, and this is where I'm feeling a little bit nervous. So let me prime a terminal offline here, and sorry, let's put that here. So I'm going to pick on a particular developer. You may have heard of him. His name is Mark Bates. He has a wonderful templating language called Plush. And so I just want to start by saying that I'm only jokingly picking on this. I'm not, if I happen to find anything wrong with this code, or if I get the fuzzer to fail in this code, that doesn't mean that the code isn't working as it's intended. We're just, what I'd like to demonstrate is just kind of like the mechanics of using it. And so that's all. So if any jokes from here on are just purely for fun, and not any kind of like indictment of the code. But anyway, so that being said, we have this Lexer test.go. And I love this bit right here. Mark Cool Bates. That's what really stood out to me. That's what made me find this, is because not only is he prolific, but he's also very modest. And so what this code does is it attempts to match the tokens of like this open, like this is very like, what do you call it? What is it, like Cold Fusion or whatever? Like very Cold Fusion-esque, I think, or something like that. Where like you have that to show like opening of template, and then you have something after that. It's like some string, and then you have kind of like this close bit right here at the end. And so what it does is it creates a new Lexer, and then it iterates over the test and tries, I'm sorry, it iterates over each test and iterates over each token that it just parsed, and it attempts to see if it found a start, a string, and an end token. But if we kind of like whittle this down, really what we're trying to do is see if we find a string. Everybody good so far? Have I lost anybody? Is anybody bored to death?
I'm good.
Okay, all right. All right. And so if we kind of like look through the code, oh, just because I edited it. Okay. All right, so if we kind of look through the code, we might see like read string. Right, and so this is a thing that actually, like when it sees an open quote, it actually reads a string. And so what I did was I had to isolate this and see if we could test just read string. And if we look at this, I already see some things that like trigger me, like personally, like internally, like I feel some things I can easily identify using fuzzing. And so we're going to try to do that. And so I'm going to, for the sake of time, since it's 7:59, I've already written a fuzzer for us. But what we'll do is we'll kind of go through the process of writing this. So what I did was I created a function whose signature is fuzz escape string quote. And it takes a testing.f value. I think by convention, we're going to call that f. And so what that does is, so what that gives us is an add method. And the add method takes, I think, a periodic list of empty interfaces. Let's see. Yes. And so what we're testing here is a function that takes a string, right? But if we were testing a function that took like a float 64 and a string and a byte slice, right? What we would supply to this is that signature. And so because it takes a periodic slice of empty interfaces, we can give it any or values of almost any type. And so later what we do is we call f.fuzz, and we pass it a function that takes a testing.t, and then or followed by values that match values that we pass into f.add, right? So with f.add and a string, my f.fuzz function is going to expect a func that takes a testing.t and a string. If I did this, right, let's say, just to be explicit, right, float 64, d.14, or whatever, right? So now my function will have to take, some value of float 64, right? But for now, we're going to keep it simple and just have it accept a string. And so since we pass it a testing.t, it behaves very similar to just a regular test. And because it takes testing.t, we could say t.log, and I just want to show that, show the value that I'm passing. And then I call new to create a new parser. And then I call the read string method. And after passing it the input. And so by default, or currently the input would be mark cool baits. I parse that input, or I attempt to scan that input by reading the string. And so what I feel like is that the intention here is to read an escaped string. And so the Go string convert conv unquote will give us should give us something close to the equivalent string representation. And so another thing I do here is if it returns an error, what that means is that, or actually I will skip this. I'll skip the skip.now or t.skip now. But please, if I forget to come back to this, somebody please remind me. But so now what I do is I test to see if what I got from read string is the same as what I expected from strconv unquote. And if they're different, then I want to complain about it. So now if I type go test run in a pattern that matches everything, and we're going to do verbose just to see the output or see the results of everything. Oh, I'm sorry. I'm getting ahead of myself. Pretend you didn't see that. All right. Well, yeah, great. So as you can see, what happened was our test ran and our fuzzer ran, and it ran with the input that we supplied in our initial corpus. And so what we could do now is we could kind of do like this kind of standard like things we might try to throw this off, right? Like we might say, well, what if we had a smiling cat face and followed by an apple. Yeah. Right. So we threw in some Unicode glyphs, although I guess they're all Unicode glyphs. But we threw in some multi-byte characters, I guess is a better way to put it, right? But we're going to put those inside the quotes, right? And so if I run this again, we'll test it, and it seems to have worked just fine, right? Everybody good so far? So we're not really even fuzzing at this point. This is very similar to like a table-driven test. And in my mind, I feel like maybe some of the tests I write is particularly fuzzers, or some tests I write might just be fuzzers by default. But is everybody good with what we've done so far? Before anybody have any questions?
No, that's good.
Okay, all right. And so now what I'm going to do is I'm going to tell it to actually start mutating the corpus. What's plural for corpus? Corpum?
Corpi?
Corpi? Okay, all right.
That
We'll go
doesn't
with
sound right. Corpuses?
Corpuses. All right, I'll do that. I'll be obviously wrong to avoid. Yeah. All right. So I'm going to say fuzz, and I'm also going to give it a pattern that will match our one fuzz function. And so what it just did was it ran my tests using those inputs that I gave it, and then it ran that mutator that I showed you in the source. And as you can see already, so I printed what it tested, and this is a string that it supplied. after mutating it. And then went, oh crap, that failed. And so now what it did is attempted to minimize that string just to the bare thing that breaks it, which is this. And then we see that we have a slice bounds out of range error, and it tried to reslice a string somewhere starting at 1. So apparently we ended up at some point with maybe a zero length string. I don't know. My goal here isn't to fix this code, but to show how it found some edge case where if I pass it this string, it would cause things to blow up. But more importantly, I think kind of the coolest thing about this is what it just said here, which is crash written to test data, fuzz escape strings, quote, and then this crazy hexadecimal string. And if we look at that, right, we're going to reset our terminal. If we look at that, oh, yeah, that's the actual string that it's applied, right? So it whittled it down to, if I give it an empty string, it'll blow up. And sure enough, I bet if we look at this code, and so just by looking at this, I get triggered by the fact that we're doing kind of sort of direct, kind of like arithmetic, just to sort of, how can I say? It doesn't look like we're treating the string as a series of rooms. We're treating the string as a series of bytes. And more importantly, it doesn't look like we're checking to see if the position we're offsetting or basically we're not checking to see if the value that we're reslicing to is out of bounds. So I don't know if, I assume that this function works the way it was expected to be written, and I assume that it works just fine. But what the fuzzer just found was that there is some input that we could supply it that would cause it to blow up. And in this case, it's simply an empty string that would cause us to blow up, which I think is kind of cool that we were able to find this. And so what we could say now, though, is that we could pretend to fix it, right? Like fuzz TestGo. So we could pretend to fix it by saying, if input equals, we'll just skip. Or just return. Yeah, we'll just return. And we'll hand wave and say that represents some fix. So what this means is that if we get an empty string in this test, that will return because indicating that the test passed. And so, but the cool thing is that file is still in the file system, and I could check this in, and so that test will continue to run. So now if I save this and say, let's pretend that fixed it, and say go test run everything. Oh, I'm sorry, with -v. As you can see, it ran the test, or ran the kind of like the bare, corpus that I provided using f.add, right? So Marcus school baits along with like cat and apples and stuff like that. But then it says it's actually running the one that it stashed on the file system in our test data directory, which is just our empty string. And so what that guards against is like regressions, right? So like, let's say I check that in and we make some more code changes. That failure is now kind of like enshrined in, if we check it in and commit it, that failure is now sort of enshrined in like the history of this code. And being there will prevent us from, hopefully prevent us from encountering this error again. And if we do, we'll see it right away without having to like remutate our data to arrive at this again. Does that make sense to everyone? Doesn't anybody else think this is like crazy awesome?
Yeah.
That's really cool.
Sounds good.
So you know what? I feel a little bit of time pressure. I guess I could kind of go on, but I think that's as much of a demonstration as I'd like to give at this point. And what I would like to do is invite everyone to kind of like play with this themselves. It's in Go. It's in the master branch of Go right now, which also includes type parameters, which is super cool. And so I feel like Go 1.18 is going to be a really big and interesting release. And I think that's all I have. I'd like to open up for questions and
Hey, George?
that,
Can we cover skip Hey, George,
Oh,
can we cover skip now?
sure, sure. So yeah, so there, all I was saying, and I guess what I wanted to get to is that I guess skip now. I wanted to do the same thing as here, right? And so what I'm doing with skip now is I want to reject, like, let's say, how can I say? So one thing that this input requires is that it's actually quoted, right? So that I have in this Go, I have like this, I forget what it's called, but sort of this this backtick, which indicates that the quote is not going to be sort of it's unescaped or like interpreted, right? And that so now we're going to have internal double quotes to mark the actual string. But what if the fuzzer generates data that's just simply invalid, right? So what we could do is we could say like, and so what I feel like if strcconv unquote returns an error, what that means is that the string that was generated was invalid in the first place. And so in this way, I could reject values that are mutated or generated by saying by doing some kind of sanity check and then skipping it if it's just like if I just need to throw it out. Another way to do that would be, for example, say like if input 0 not equal to quote and input len input -1 and barring any kind of panic. Well, I guess, all right. So if input doesn't equal empty string and input 0 doesn't equal open quote or input end doesn't equal double quote, right? That means that this input just doesn't meet our requirements. We're not interested in testing this because our input should have an opening quote and a closing quote. So now we can say t.skip now, which means just stop what you're doing, skip this test. This is bogus, right? So that was a thing I wanted to demonstrate with t.skip now. And I think that's like a proper way of throwing out what we consider to be invalid input generated by the mutator. I think that's all I have. And I invite you to read the source. It's super duper approachable. What I find is that reading Go source is where I've learned the most about Go. And yeah, it's actually, like I said, a fun read, especially like the mutators like XORing and bit flipping and that kind of thing. Like, again, I imagine it had to be like super fun to write that stuff. That's all I got, guys. I hope you learned something. If you have any more questions, I'm happy to try to answer them.
Absolutely, and thank you so much for that. That was great. I know a lot of people. You kept a full audience the entire time, so that's usually a good indicator that people are paying attention. Anybody else? Anybody have any questions that they'd like to? We don't have to shut down or anything at the moment. I mean,
sure. I have a couple questions.
Please.
I've got an easy one, and then I've got a hard one.
Okay, I'll be the judge of both of those.
So you mentioned briefly you were talking about the I guess the fuzzing cache. It was the file name with the very long. You said something.
That wasn't the fuzz cache. That was the actual output generated by a failed fuzz.
Okay.
Failed test. I'm sorry. Go ahead. What were you saying?
No. Okay. Thank you for the clarification. But you very briefly said something about checking it in. Is that something that you would put under source control in a repo?
Absolutely. Absolutely.
Would be used across development boxes from different team members?
Absolutely. So again, what that represents is input that the fuzzer found that you didn't anticipate that caused it to fail. And so it would be a shame if that information was lost, right? So what I would assume the workflow or what I would assume would happen is that the fuzzer would find that, you go, oh shit, I'm sorry, well, oh crap, I got to fix this. And so you then go and fix it until that test passes. And well, so now I guess there's two branches there, right? You might go, oh crap, I need or you might go, oh, that input is just bogus, right? And maybe you do this like skip thing where you go like, where you write some filter for it to tell the test to just skip that sort of invalid input. But I think the more likely branch is that you'll go, oh crap, the fuzzer just found a new bug, and then go and fix it, and then rerun the test until that stashed test actually passes. And so now you want to preserve that, right? And so I guess you could go through and add it directly to your corpus, right? You might be able to say like, f.add
as a manual.
Yeah, right. That you could do that, right? But I think it's so beautiful to be able to say, like git add test data dot or whatever, however you want to do it, right? Fuzz, escape, fuzz, right? Or that, whatever, however whatever the mechanics of checking in. I think there's kind of I think there's a beauty to that. I think that works really well. Does that make sense? Or
it does. So it aligns with something that I heard or read, is that sometimes fuzzing can take a lot of time and processor, so that like having a dedicated fuzz box is something that's very reasonable. And I imagine that would be the kind of thing where it would generate these files, and then you'd put them into source control, and they would filter down to, individual developers, and then they wouldn't have to, respend that time and that energy rediscovering those things, like you said.
Yeah, so I agree. Like, so that would prevent you having to run the fuzzer until it happened on that particular input again. I see that as almost secondary to, again, enshrining that input in a way that allows you to prevent regressions, right? Like I don't care about CPU cycles too much. Most of our desktops are probably like more than powerful enough to do this on without, anyway, I guess my point is, yes, I completely agree. The thing that like I think is most cool is that we encode that and preserve it. But yes, I agree. It's also cool that it prevents our fuzz box, or prevents us from having to fuzz to that point again as well. Yeah, I agree. Was that the hard question, or?
No, I think that was the easy question.
Oh crap! All right, here we go.
So at the top of the fuzz talk, you had said something about it being difficult, that it wasn't necessarily the easiest thing to implement or to reason about. How do we bring this as a practice into teams that are already doing little to no testing?
Oh, well, so when you say difficult to implement, so I think fundamentally, when you say doing little to no testing, I just want to say it's a travesty if you're on a team programming in Go and you're doing little to no testing. It's
I know.
Yeah. So that's the first part, right? Is that Go makes testing so easy, and that I get in it, but I guess instilling testing as like a kind of practice that you do is that's a cultural thing, and you're right, that's impossible for me to answer. Like where I work, there's some things I wish I could just go and just dictate and say, no, we should do this. But we have so many different opinions that that sometimes but testing is something I think we all could agree on that it should be done. And so once you establish that you should do testing, I think then the question of when is fuzzing appropriate is a harder question. And what I tried to outline were at least the scenarios or the types of functions that I saw as like fuzzable, right? And again, those are functions that are easy to kind of verify. Things with deterministic like outputs, and so those are just. And so what I find is that that's actually a smaller subset of problems. Well, so I guess in testing in general, you have like you should have deterministic inputs and outputs. But what I found is that there's not many there's not many problems that are suitable for just throwing random data at. So I think that's a big thing is most problems have kind of a constrained set of inputs, and most inputs wouldn't make much sense. But as we demonstrated, it might be useful. Like, so let's say for a you know what? I'm sorry, I'm having a hard time to like thinking up something, but I guess my point.
No worries.
I guess my point about that slide is that I found it difficult to find scenarios, not difficult, challenging to find scenarios where fuzzing is appropriate. But what I hope is that as I continue to use it and as I continue to think about fuzzing, that more of those scenarios will become apparent to me, and maybe everything's fuzzable if you try hard enough, kind of thing. Maybe, I don't know. So yeah, that's it. All right. I'm sorry. I feel like that's an unsatisfying answer, but I guess
no. I think that's it's helpful. It's informational. There's a lot of stuff there.
Okay. I'm sorry if I kind of like rambled and meandered, but that was just my take on it. Yeah. Hey, anybody else, or is that are you satisfied with that?
Yeah, those are my questions. If anyone else has anything, go ahead.
Hi, Jose here. As you were speaking and going through fuzzing, I was actually thinking quite maybe the opposite of what you were saying. I think for situations where unit testing or functional testing is a constraint on time. So let's say you're pressed to deliver or pressed for something. At the very least, fuzzing will give you some sort of air cover from these kind of cases where, as you say, bad data can expose you, right? So when you're exposing the service externally, having something like this could be one of those things that can really save you. I saw it as a quick way to have, at the very least, some sort of air cover up and running. We're all developers here. Sometimes we're under pressure from product or project management to just get your tickets through in the sprint and get your code out there.
Yeah.
And testing always, tends to be the easy thing to fall by the wayside.
Well, personally, I think though it would be wrong not to be thoughtful or to be, how can I say? I think it'd be wrong not to try your best to provide a solid starting corpus, right? I don't think it's possible, or I don't think it's valid to just say, for example, empty string, right? And just let the fuzzer take the wheel, right? And just let it kind of run crazy with it, right? So I think because your initial corpus does influence how it fuzzes, right? So I think you still have to be thoughtful about it. I don't think it can, I don't even think it remotely like removes that responsibility from you, if that makes sense. Would you agree with that, or?
Yeah, it makes sense. I like it. Thanks.
Yeah. I'm sorry if it sounds kind of opinionated, but like I would like, if we started fuzzing at work and I saw that, I would like fall out of my chair and be like, yeah, that doesn't make any sense.
Are you saying that that's the case because the empty string is not at all helpful?
Well, again, we start with this data and we mutate it, right? So it's not like, and so I think you're the one who mentioned like CPU, right?
Mm-hmm.
How long do you think it would take sort of, an infinite amount of monkeys to come up with like my cat face mark, cool Bates Apple thing, right? So my point is, with my understanding of how the code works, I gave it some multi-byte Unicode values that I think the fuzzer would never, well, it actually would come up with it pretty quickly, but maybe not that string exactly. But I guess my point is, for more complex inputs, the fuzzer will probably almost never arrive or fall on a good data set. That makes sense.
It does. And I think in spirit, I agree with you. I'm just playing the other side a little bit.
Sure, sure.
It's, and I guess from my personal experience, a lot of this depends on the team. I think an empty value is absolutely ridiculous, but creating a fuzz test with only one corpus might be a good start, depending on the culture of the team.
Well, so would you normally do this with like a table test, right? And so basically my initial corpus would be comprised of the things that I would normally put in a table, in my table driven test. And this would actually behave in a very similar way to that. Would you agree? And so I don't see any reason, at least, to minimize the amount of data you put here. I guess what I'm saying is the impression I got was the other gentleman was saying, well, and I reckon, please understand that I recognize maybe this isn't exactly what you said, and I'm making like an extreme example out of this, but
sure.
What I wouldn't want to see is you hesitate to add data to the corpus or add values to the corpus because you think the fuzzer is going to like pick up the slack for you, I guess is my point. Does that make sense?
Absolutely. Absolutely.
Okay.
And the way that I understand the fuzzing is that it takes your initial things, and like you've said, it mutates them. So giving it a good starting place is going to get closer to where you want it to be than if you don't give it anything at all.
Right. So that's it. So like I wouldn't lean on the fuzzer to like do all of my testing for me, I guess is my point. You know, I'd still do the work of providing some good solid tests, and then so.
Ideally.
Yeah. Well, more than ideally, right? So I feel like we keep going back to this like on my team or in an ideal world kind of thing. I guess I'd have to inject like a very strong opinion here and say like, no, like always, right? Treat this, you know, we're testing here. We should never, I don't think this is a place where we should like take shortcuts. If you have data, if you could think of test cases, put it in there. Don't go, I'm not gonna put that. I'm just gonna let the fuzzer find stuff and then commit all the things it finds. That's it. I'm sorry if that comes off as too strong, but I just want to be clear that my opinion is that you should add as much data to your corpus as you reasonably can, always.
Yes. No, and I don't think that's too strong.
I felt a but coming after that. And
well,
my point is that I'm sorry, go ahead.
The but is, you know, I can't make my teammates write tests. You know,
right.
I can take responsibility. Testing always. When I don't write tests, that's on me. But I can't make my teammates write tests.
Yeah, that's a, you know, again, I think that's a bigger issue, and I'm guilty of it, right? But like again, Go makes testing like integral to like development process. I feel like to some degree, if you're not like testing first, like if you're not like, and I'm not talking about like test-driven development, I'm just saying I sometimes start by writing a test, just, you know, for lack of a main function, right? If you just need like a loop or something to exercise the code you're writing, start with a test. And so through testing, so much is like revealed, right? Like you find out where it's convenient to like use interfaces. You find out like, anyway, so I feel like the first problem you have is instilling testing as part of your culture, right? And then after that, I think, you know, once you do that, and once you get kind of a good testing culture, I feel like being diligent about adding data to your fuzzing corpus will kind of come naturally. I feel like I'm pontificating now, and that's what I don't want to do. I don't want to like.
No, I don't get that vibe. Just.
Yeah, so that's all I got. Yeah, that's what I have to say about that.
Thank you.
Yeah, no problem. So I learned something today. The whole 2006 Monday thing. That's awesome. Yeah, anybody else have any feedback or anything I should know, or any complaints? All right, well, thank you for your time. I really appreciate you guys being here, and I really enjoyed talking about this today. And if you you can contact me, my email address is, well, I think I put my contact crap in the slide. Yeah, so ayan@ayan.net is my email address. Ayan George is my Twitter handle. I'm usually not public, so but feel free to follow me if you like. If you already follow me, I'm so sorry for the things that you see there. And